Level 0. Nobody warns you about the quiet ones. Somewhere in the Pacific Ocean right now, a wave is moving. 3 hours of travel already behind it. 800 kilometers from the nearest coastline, moving at the speed of a commercial jet. Completely invisible. Ships have crossed over it without feeling a thing. Satellites registered a surface change of barely half a meter. In 40 minutes, it hits shallow water. And all that stored energy compressed across hundreds of kilometers of open ocean will have nowhere left to go but up. This is how tsunamis begin. Not with a roar, not with a wall of water on the horizon. With silence. With the sea pulling back in a way it was never supposed to. The horizon looks wrong. The beach looks wrong. Everything looks like an opportunity to walk closer and investigate, and that is exactly when the countdown ends. Coastal communities have been noticing this for centuries and doing the wrong thing. The seafloor appears. Fish lie stranded on sand. The water retreats further than anyone has ever seen. People walk toward it, curious, calm, because nothing in human instinct prepares you for the idea that the ocean is loading. The exposure of the seafloor is not an invitation. It is a countdown. That retreat has a name, drawback. The ocean inhaling before it screams, and every person who has ever walked toward the exposed seafloor instead of away from it has misread that inhale as an invitation. The most dangerous moment in a tsunami is not the wave. It is the 60 seconds before the wave when the water is gone and the world looks quiet and curious people walk the wrong direction. The word tsunami is Japanese. Tsu means harbor. Nami means wave, named by fishermen who left port in calm water, worked a full day at sea, and came home to find their entire village gone. No warning they had missed, no wreckage on the water, no explanation visible from the boat, just absence where everything used to be and the slow understanding, arriving too late to be useful, that the sea had done something while they were away and left no record except the silence. What separates a tsunami from every other wave on Earth is not height. It is wavelength. A storm wave stretches 150 meters crest to crest. A tsunami wavelength can reach 500 kilometers, the distance from London to Edinburgh. That is not a wave in any sense the word usually implies. That is a moving wall of water the width of a country, every layer of it pushing in the same direction simultaneously. And it moves not just on the surface, but as a full column of water from surface to ocean floor, every drop carrying the same energy toward the same point. When that column hits a beach, it does not break. It simply does not stop. Scientists measure tsunami intensity on the Imamura Iida scale from -5 to +4, based on maximum wave height at shore. Each step roughly doubles the destructive force. The scale was designed to give researchers a common language for comparing events across history and geography, a standardized way of saying this one was bigger than that one, and here is by how much. We follow that scale today, starting at its absolute floor, where even the minimum is already enough to kill. And what you are about to see is that the floor is not where the story starts. It is just where it stops being possible to look away. Level 1. 1 meter. The height of a kitchen counter. That sounds survivable. You have stood in bigger waves on a summer holiday. That exact instinct is what gets people killed at this level. A beach wave crests and retreats in seconds. Its energy dies against the sand. A tsunami, even at this level, is a column of ocean thousands of meters deep, every layer moving in the same direction. That 1 meter crest does not crash and pull back. It pushes, steadily, for 3, 4, 5 full minutes without stopping, flooding inland like a room filling with water and no drain. A beach wave is a visitor. A tsunami is a takeover. The difference is persistence. The difference is that the water does not stop, and the things in its way, furniture, vehicles, people, were never designed to withstand something that simply does not stop moving in the same direction. The current it generates reaches several meters per second, fast enough to knock a standing adult off their feet, fast enough to turn a timber plank into a battering ram, fast enough to drag a swimmer under before they understand what is happening. The current does not announce itself either. It simply accelerates, and by the time you feel it, you are already in it. At 1 meter, the water that covers your ankles is moving with enough force to throw you down. At knee height, most adults cannot stay upright. At waist height, no one can. In 1960, the Great Chilean Earthquake at magnitude 9.5 launched a tsunami across the entire Pacific. By the time it reached Hawaii 15 hours later, enormous energy had bled off. In some locations, it arrived under 1 meter tall. It still killed 61 people in Hilo. People who had received official warnings, people who chose to watch from what they believed was a safe distance, people who had looked at the water, made a judgment, and been wrong by the margin of a single meter. The wave did not negotiate with their assessment of the risk. It did not distinguish between a safe distance and an unsafe one. It simply rose and kept rising. The lesson of Hilo is not that the warning system failed. The warning worked perfectly. Every person who died had been told to leave and chose to stay. The lesson is that 1 meter of water, if you are standing in it when it moves, is enough to kill you, and that knowing a tsunami is coming is not the same as understanding what a tsunami actually is. Harbors are particularly dangerous at this level. Their narrow enclosed geometry funnels and amplifies incoming energy. Boats tied at docks become wrecking balls, snapping moorings and slamming into infrastructure. Surge and backwash create violent, unpredictable currents that no experienced ocean swimmer can navigate. The harbor that looks like shelter becomes the most dangerous place on the coast the moment the wave arrives, a confined space where the water has nowhere to go except into everything around it. Iida scale 0, the floor, the minimum this phenomenon produces, and it already has a body count attached to it that grows with every event where someone decided the warning did not apply to them personally. So what happens when the scale climbs and the ocean stops giving you any warning at all? Level 2. A wave does not have to be enormous to erase a village. It just has to be the right height in the right place at the right speed. And at Iida scale +1, all three conditions arrive simultaneously, without negotiation and without any warning you can realistically act on in time. At Iida scale +1, wave heights reach 3 to 5 meters at shore. The difference between this and scale 0 is not just size. It is behavior. At this height, the wave does not inconvenience. It carries cars, timber, fishing boats, concrete blocks, all of it incorporated into the churning mass and used to dismantle everything further inland. Survivors describe not water, but a grinding wall of debris moving at running pace through streets, taking apart everything it contacts. The noise is what people remember most, not the roar of water, but the low, continuous grinding crash of a neighborhood being fed through itself at speed. People who have heard it describe the sound as something that has no comparison in normal life. It is not loud in the way thunder is loud. It is loud in the way that something permanent and irreversible is loud. On September 29, 2009, a magnitude 8.1 earthquake struck near Samoa. Most of the affected coastline was hit by waves in the 3 to 6 meter range. The village of Paloa on Tutuila was destroyed entirely. Survivors described having under 10 minutes from the moment the shaking stopped to the moment water arrived. 10 minutes to find your children, reach high ground, and commit to running without looking back. And those 10 minutes only existed because the island happened to be far enough from the epicenter. Other parts of the coastline had less than 5. Some coastal communities sitting directly above the fault line had no warning time at all. The sea was retreating before the shaking even stopped. 192 people across the region did not make it. Here is the detail that keeps killing people who already survived the first impact. Tsunamis almost never arrive as a single wave. They travel in sets, crests separated by 10 to 60-minute intervals. The first wave is often not the largest. Survivors who return to the coast after the first wave to search for family or check on property have been killed by the second. Emergency responders call it the secondary wave trap. It has claimed lives across dozens of documented events worldwide, in every ocean basin in every decade that has records. The sea retreats. People read it as a sign of safety. They walk back toward the waterline. They take out their phones. They call out names. The second wave does not care about any of that. It has been moving toward the shore since the moment the earthquake happened, and it arrives on its own schedule entirely. No announcement, no second warning, just the water rising again from a coastline people were just beginning to think was safe, rising faster and higher than the first wave because the first wave removed everything that might have slowed it down. And at 10 meters, it does not leave anything standing that is worth returning to. Level 3. 10 meters, a 3-story building, moving at 50 kilometers per hour, carrying every piece of everything it has already destroyed, and it does not slow down when it hits a wall. At this scale, conventional construction collapses. Reinforced concrete buildings, structures rated to survive major earthquakes, get undermined from below, foundations scoured away, walls failing under lateral force no architect designed for. The pressure a 10-meter tsunami exerts on a vertical surface exceeds 4,000 kilograms per square meter. Most buildings were simply never built to absorb force from that direction. They were engineered to stand against gravity, against wind, against vertical shaking. None of that engineering accounts for a wall of water and debris moving horizontally at the speed of a fast car, with the entire mass of the ocean behind it. On July 12, 1993, a magnitude 7.8 earthquake struck off Hokkaido, Japan. The tsunami reached Okushiri Island with waves averaging 10 to 20 meters along the coastline. The town of Aone was completely gone within minutes. Gas line fires burned through the debris while water was still moving inland. 230 people died despite Japan operating one of the most advanced warning systems on Earth. Okushiri was simply too close to the earthquake source. The warning system existed. There was no time to use it. Warning time was measured in minutes, not the hours that make real evacuation possible. On a small island with limited roads, there is no meaningful distance between the shore and everywhere that matters. The people who survived were the ones who ran immediately, without waiting to confirm what they suspected. The ones who waited to be certain did not get the chance to be certain about anything again. At this intensity, the wave penetrates kilometers inland across flat terrain. Agricultural land becomes saltwater for years. Fishing communities lose boats, docks, and livelihoods simultaneously in the same 3 minutes. The smell of the sea moves inland where it was never supposed to reach. Economic damage outlasts physical destruction by a decade or more. Entire industries built around a coastline simply disappear, and the people who depended on them spend years rebuilding what the water took in an afternoon. A town can slowly rebuild its buildings in 5 years. Rebuilding the fishing fleet and institutional knowledge takes far longer. After 1993, Japan built tsunami evacuation towers along vulnerable coastlines, reinforced concrete platforms whose only purpose is somewhere to climb. Governments argued about the cost for years. Then the next disaster came and people ran to them and survived because of them. Japan also built enormous seawalls, 15 meters tall, billions of yen. Structures that communities built their safety around, and that changed the way people related to the coastline they lived beside. Some towns reported that the seawall made people feel so safe that they stopped teaching children the evacuation routes. In some locations, the walls held. In others, the next tsunami went over them. Japan built to match the last disaster. The one that followed had completely different dimensions that no living engineer had been tasked with accounting for, because nothing that large had happened in recorded Japanese history. The ocean does not study the previous exam. The next level proves it. Level 4, March 11th, 2011, 2:46 p.m., Japan. The ground shook and did not stop for 6 minutes. Magnitude 9.1. The most powerful earthquake ever recorded in Japan. The seafloor off Honshu lurched eastward by 24 meters. Honshu itself moved 2.4 meters to the east. Earth's rotational axis shifted. The length of the day shortened by 1.8 microseconds. The planet changed shape before the first wave reached shore. 6 minutes of continuous shaking is something most people will never experience. Most earthquakes last under 30 seconds. 6 minutes feels like the ground has decided to stop being reliable, and by the time it finally stops, you already understand that whatever comes next will not be normal. Along the Sanriku coast, waves reached 40 meters in the most amplified inlets. Rikuzen Kata was erased. Of 8,000 homes, fewer than 200 remained. Its coastal pine forest of 70,000 trees that had lined that coast for generations, a landmark the city was known for, and was stripped to bare ground in under 4 minutes. The trees did not bend. They did not break in the conventional sense. They were simply gone, roots and all, as if they had never been planted. One tree survived. Japan preserved it behind glass as a national monument, the miracle pine. Visitors still make the trip to see it, a single preserved tree standing in a field where a forest used to be, which is a more honest image of what happened than any official report could provide. The wave traveled 10 kilometers inland. Kamaishi had spent decades building the world's deepest offshore tsunami breakwater, a Guinness World Record structure built so this could not happen. Engineers had modeled the scenarios. The structure had been tested against simulations. None of the simulations were large enough. The breakwater slowed the wave slightly and reduced its height by an estimated 40% at the harbor entrance, and still the tsunami cleared it and destroyed the city. The ocean had not been consulted during the engineering process. It arrived with a different number than the one on the blueprints. Nearly 20,000 people died. 500,000 were displaced from their homes. Then it compounded in a way nobody had fully prepared for. Fukushima Daiichi nuclear plant was struck by a 14-meter wave, nearly double what its seawall was rated to withstand. Generators flooded, cooling failed. 3 reactors melted down over 72 hours. It was specifically the wave that broke it, specifically those 2 or 3 meters of gap between the wall height and the water height that turned a seismic event into a nuclear disaster. 150,000 people were evacuated from the surrounding region, many permanently. Some zones remain closed today. The cleanup extends to 2051, 40 years of work caused by a single wave that lasted under 5 minutes. Japan, the most tsunami-prepared nation on Earth. The nation that had built evacuation towers, written the textbooks, run the drills, and funded the seawalls. Still, 20,000 dead. Still, a nuclear exclusion zone. Still, communities that simply do not exist anymore. The geological record holds events that make Tohoku look like a warning shot. And some of those events were witnessed by no civilization that survived long enough to write anything down. But the ocean left its own records, and we have learned how to read them. Level 5. This is the top of the official scale. It is not the top of what the ocean can do. August 27th, 1883. Krakatoa, Indonesia. The volcano had been rumbling for months. Locals had grown used to it the way people grow used to any persistent background noise as something normal and not worth evacuating over. Then it crossed a threshold no one had prepared for. The explosion was heard 4,800 kilometers away in Australia, the loudest confirmed sound in recorded human history. As the magma chamber emptied, the entire volcanic cone collapsed directly into the sea in a matter of minutes. Waves reached 37 meters along the Sunda Strait. The town of Merrick was not partially damaged or left half-standing. It was obliterated, every structure and foundation stripped cleanly from the surface of the ground. A steamship called the Barao was carried 3 kilometers inland and left in a jungle clearing. The crew were all dead. The ship became a landmark in the jungle, something locals passed for decades, a rusting reminder of a morning that rewrote the coast. Its hull sat there as a monument to what water can accomplish in under 4 minutes. 36,000 people died, the vast majority killed by water, not fire. Iida scale +4 marks the upper boundary of the official framework. Krakatoa sits at that ceiling, a documented and historically recorded event where an entire volcanic island collapsed and rewrote the coastline of a strait in a single morning. But 1958 tells you what happens when the scale runs out of room. Lituya Bay, Alaska. A magnitude 7.8 earthquake sent a massive rock slide into a narrow enclosed inlet. 30 million cubic meters of rock fell into confined water. The displaced mass surged up the opposite mountainside to 524 meters, the tallest wave ever recorded in human history. The forest on one side of the bay was stripped to bare bedrock in seconds. Trees that had stood for centuries were gone before the sound of the rock slide finished echoing. One fishing boat rode the crest, its crew looking down at treetops as they passed over. They survived by keeping the boat pointed into the wave and riding it as it crested. Afterward, they described feeling no fear in that moment, only the strange, suspended sensation of being somewhere no human had ever been, at a height that had no name. 2 others were not recovered. 524 meters, taller than the Empire State Building, generated not by a full ocean rupture but by rock falling into confined water. The bay geometry concentrated everything. In open ocean, the same rock slide would have produced a fraction of that height, which is both reassuring and deeply not reassuring when you consider what the open ocean prehistoric collapses must have involved to produce similar waves without a bay to help them. The geological record contains evidence of exactly those collapses. It is not speculative. The deposits are there, the displaced coral is there, the boulders that could only have been moved by water are sitting on hillsides where no water should ever have reached. 524 meters, rock into water. A single bay doing all the work. So what happens when the open ocean doesn't need one?